Alright, so today we're going to have our quiz at the end of class on plotting. And before we do our quiz, we're going to be going over kind of another workshop, kind of like we did last time. And basically this workshop, apart from just helping you in general for plotting and with some of the new functions that we're learning, it's also going to help you with the project. We're going to go over a lot of the techniques that you're going to need for the project, which we'll talk about on Wednesday. And I'm going to assign it on Wednesday. So you can start working on it during spring break if you want. If I was you, I would at least look at it. But even after spring break, you're going to have 4 weeks to work on the project. So you're going to have a lot of time to work on it. All right, so first up, let's go over here. Yeah, the webcam thing, I'm actually not even using Zoom right now with my webcam because Zoom is still kind of, I just hate using Zoom. So this is kind of separate from Zoom, but I like this method. Okay, so I uploaded some new data just literally like, I don't know, 3 minutes ago for the workshop that we're doing today. So go to the page for today and so, right here. And you're going to download this data. It's called Angels 2020. So download that and then we're going to do a whole new workshop with this. And you'll also notice that this is 6 megs, so it's bigger than the data that we used last time. Still really small, but something that, you might want to take note of. Our script is going to run a little slower because of that. Alright, so you're going to click here to download it. And again, you're going to want to save it in whatever directory that you have for your script. So I would go to this class, then I'll go, in my case, to my lectures. And I'm going to save it in here, and this is where my script is going to be as well. Oh yeah, also, before our quiz starts, if I don't remember, then somebody yell at me again. So like at 3:25, if I forget, tell me in the chat to explain the quiz. So the quiz, it's on plotting, but usually for the quiz, I have you kind of fill in the blank. But this time around, you're going to just copy and paste your code in a text box. So I think it's pretty self-explanatory, but still, a little before the quiz starts at like 3:25, let me know to explain the quiz format so I can be, really clear on that. But basically, you're going to type all of your code in MATLAB to make a plot, and then you'll just copy and paste all of that code into a text box inside of Canvas. So you're only going to make there's only one problem for the quiz. It's going to be 15 minutes like usual. Okay, so I just want to recap. We're going to be doing a workshop today, and then on Wednesday, I'm going to go over the project. And yeah. Oh yeah, homework 3, I need to grade that still, but if you did it, you'll get 100%. And then homework 4, that's due today, so that's on plotting. Oops. Oh, here's my webcam. Okay. Alright, so did everyone download the new data called Angels 2020? Because we're going to get started with that new data right away. Or if you just want to follow along, you could do that too. So basically, we're going to be making this figure here. We're going to be making 2 figures for this workshop, and if we also have more time, we'll even do something else. So this is the figure we're going to make. It looks pretty simple, but it's a little involved to get there. And then the other one we're going to make is this one. Okay, so let's first start our new script here. Angels Data Workshop. Alright, so we're going to import our data. So for the slides that I have here, I tried, I think I went over all of the code for these slides. So we'll kind of try to follow along like that. So the first thing we have to do is import our data. So just so I don't have to type a ton, I'm just going to call this table T. And we're going to say read table. And the new data that we're using is called angels_2020.csv. My slide is inaccurate here. I forgot to change that. Okay, so 2 questions. Before the quiz, can we go over tick stuff and tick labels plus the legend? Yeah, if we have time, I'll go over that. So the legend, I'm thinking if we're doing that in here. We'll go over the legend in one of the plots we're making. And we're also actually kind of going over at least tick labels in this plot. But we could talk about ticks as well too. You might need to remind me about that too if I forget, so I'll try to get to that, but there's no guarantee, at least for the ticks. Okay, and another question, do we have to input AX equals GCA in our code for the quiz? Maybe. It depends on what we're doing. So if you're like editing, you know, in our homework we had a problem where we wanted to change the exponents that we saw along the y-axis. So in that case, you would have to do AX equals GCA because you need to access your axis properties. So it depends, right? If you're editing something where you need to access those properties, then you have to do it. And okay, so your table is 911 by 89. I think that's actually right. Let's run this though. It's a really big table. It's 9,000. Oh yeah, I read your numbers wrong. Yep. So 9,000 rows and we have 89 columns, so it's massive. Oh yeah, hold on, let me go to Discord really quick, guys, because I also mentioned something in there for the quiz. Okay, let me share my screen again. So just before I forget, just because one of you asked if we have to use AX equals GCA on the quiz. So you again, that depends, right? For some things you have to use that command to access those axis properties. So you might have to use that, but on the quiz, you're not going to be tested on arguments like, you know, figure, position, invisible, and on. None of that. You don't have to do that. You're not going to be graded on that part. I actually show on the quiz too for what you don't need to worry about. So we'll go over that too. And I had a few questions on what position meant. So that's to specify the size of the figure. And we'll go over that in the plots that we produced today too. Alright, so let's get started here. So we imported our table. Oh, I went too far. Okay, so we imported our table, and let's take a look at this. So it's 9,000 rows, and there's 89 columns, so yes, it's a ton of stuff here. And what we're going to be first looking at is the column. It's pretty far. Column 54, it's called launch speed. So all that is how fast the ball is hit, or how fast the ball is traveling once it's hit. So we're going to look at this column, and basically we want to make a bar graph for how often 3 of our players here hit a ball over 100 miles per hour. So, you know, you see that Mike Trout, he hits it about 7.5% of the time, he'll hit a ball over 100 miles per hour. David Fletcher, poor guy, he's weak. He's not hitting it very often, over 100 miles per hour. And then Shohei Ohtani, about 5% of the time. Okay, so we're going to be doing that. Alright, and one of the things that we're going to do right away is convert. I keep going too far here. Okay, here we are. So we're going to convert that column for launch speed into a string. So right now, if I go into the command window and I type in class of T, that's our table, and I do dot launch speed. MATLAB will tell us that it's a cell. So later on, this is going to have to be a string. You know, this is basically a cell array, which we're about to talk about too. I know there's a question on the difference of a cell array and a numeric array last time. So we're just about to go over that. But right now, we're going to convert that column vector launch speed into a string array. Because again, later on, you'll see that we have to have this as a string array instead of a cell. So we'll do this for now, and we'll explain it in more depth later. So when I say we're converting it to, we're actually converting it to a double, sorry, not a string array, but a double. So that means it's a numeric array. So we'll do t.launchSpeed equals string to double. So that's the function we're using here. That'll convert this from, you know, the function is called string to double, but this will still also convert a cell to a double. Alright, so if we run our code now and we type in class of t.launchSpeed, now it's a double. So it's just a number, that's it. Alright, so next thing we want to do is find the indices for the players that we have. So for our plot here, or our bar chart, we want to get data for Mike Trout, David Fletcher, and Shohei Ohtani. So when I say that we want to find the indices for these players, basically we want to find the rows where they show up every single time in our table. So let's open up our table again. If I go all the way over here, I can look in column 6 and you see player name. And basically we want to get all of the rows for Mike Trout, Shohei Ohtani, and David Fletcher. So you see Ohtani, he shows up here. We want to get all of those rows, these rows, this row, and so on. Same thing for Fletcher, he shows up here and here. You get the idea. So we want to get all of those indices so we can kind of gather our data for these 3 players. Alright, and then, you know, because this is some new stuff to you guys, whenever you have a question, be sure to either use your mic or put it in the chat, because this stuff is going to be important for your project. Okay, so what I'm going to do now is make a cell array, which we'll discuss what that is. So we'll say angels_ind, standing for indices. And I'll do 1, 1. Let's see, if I run this, will this show up there? No, it's not. Okay, for now, I'll just do this. So if I open this up, angels_ind, this is a cell array. So you see up here, it says it's a 1x1 cell. And basically, to make a cell array, we have to use these curly braces here. So that's different than what we did before throughout the class. If we did something like 1, 1. So if we have just regular parentheses here and we run our code and we look over here, it's a 1x1 double, meaning that this is a 1x1 numeric array. But if I want to make a cell array in MATLAB, I use the curly brackets. Okay, so I'll run this again, and this will change to a 1x1 cell. Okay, so now let's make this cell array for Mike Trout, where we get all of those rows where he appears in the table. So I'm going to use 2 different functions, or one function here. And I'm not sure if we went over this last class or not. I kind of mix all of these workshops together up now. So I'm not sure if we talked about the find function. So basically the find function finds indices. So if I run this for find t.playerName, this is the table t, and player name, that's our column, and we want to find the indices for every single time that Mike Trout shows up. So to do this, I'm going to say find when the player name is equal to the string of Trout, Mike. Because if we look at our table here again, I closed out of it. So if we look at our table in column 6, That's called player name. And this is formatted where we have the last name, a comma, and then a space, and then the first name. So we need to put it in that same kind of format right here. Okay, so let's run this right now. And then if I open this up again, Angels_IND, you see that in this cell here, we have a numeric array in that cell. So in cell 1, we have a 1023 by 1 column vector. So I can open this up by double clicking on it. All right, and then you see all of these numbers. And all of these numbers correspond to the index or the row in our table. So let's take a look at this. Let's pull this out here. So let's confirm that we're actually getting all of the rows that contain Mike Trout in our table. So we're going to go over here and let's scroll down to row 301. All right, here we go. So we got 301 to 308, and that's what we see right here for the indices. And then it says that he shows up again in row 392. Let's check it out. 392, and then here's Mike Trout once again. And we'll check one more, 397. Yep, there he is again. All right, so does that make sense? We're getting all of the rows that contain Mike Trout. All right. And then we want to do the same thing for our other two players. So I'm going to copy and paste this line. And now what we're going to do is change our cell array, or we're going to create a whole new cell, basically. Okay, so we're going to make one for David Fletcher, and then we're going to make one for Shohei Ohtani. Okay, and then we have Ohtani.
So I noticed for the names you use double quotes instead of single quotes.
Mm-hmm. Yeah.
Why is that?
Yeah, it actually might work with single quotes. Let's try it. I don't think it did. So if we use double quotes though, that's how we define a string in MATLAB. And single quotes is usually a character array. So first let's try this. Okay, yeah, it's not gonna work. So it's reading this as a cell, but if I was going to define, like if I typed in class of Trout, Mike, where I have these single quotes, that should be a character array, meaning that MATLAB interprets it just letter by letter or number by number. But if we want to look when a Mike Trout shows up, we have to put it in double quotes, and that'll be read as a string array or a string. So now MATLAB is actually looking at that entire name, Trout, and then a comma, and then his entire name, Mike. So sometimes it's, MATLAB can be a little weird where sometimes either double quotes or single quotes works, but in this case it has to be double quotes. Alright, and then there's a question, how would it change if we had parentheses and not curly brackets? So we'll actually show that right now. So we made our two other arrays here. Or, yeah, basically arrays. Oops, let me uncomment them. Okay, let's run this. Alright, so we made our two other cells that contain different arrays. So you see in cell 1, this corresponds to right here where we had these curly brackets and 1, 1. We're in row 1 and column 1. Our next one, we're in row 1, column 2, so that's this cell. And then we have 1, 3, that's this cell over here. So if you look at this, you see that all of these different arrays that are inside of these cells, there are different lengths. So cell 1 has a numeric array of 1023 rows. Column 2 here, or cell 2, has an array of 906 rows. And 3 has 739 rows. So that's why we're making a cell array here and not like a regular array that contains all of this data. So basically, imagine that instead of having these cells, I wanted to show all 1023 rows here, all 906 rows here, and all 739 rows here. I won't be able to do that because MATLAB wants an array to be the same size. So basically, I would need to have 1023 rows here, and I would also need to have 1023 rows here and also here. So if we try to change this, instead of curly brackets now, let's try to use regular parentheses, which again, that would be to make a numeric array. So if we try this now, we're going to get an error. Alright, let's change this. Okay, so let's run it now. Alright, and then we get this error that says unable to perform assignment because the indices on the left side aren't compatible with the size of the right side. So basically that's MATLAB's best guess for why we have this error. But basically the issue is that all of these numeric arrays that we have for each of these players, they're a different length. And if we're trying to put them in one array, we can't do it because they're different sizes. Alright, so that's why we use these curly brackets up here to make a cell array, because that cell array can contain numeric arrays of different lengths. Alright, does that make sense, or anyone need another explanation for that? Because that's a key concept to understand here. Okay. I'll say one more time anyway. So when we use curly brackets in MATLAB, we use them to make a cell array, which is what we see over here. So all of this is a 1x3 cell array, and inside each of these cells, we have a numeric array. So in cell 1, we have a numeric array that has 1023 rows, and in cell 2, we have a numeric array of 906 rows, and same thing for cell 3, we have 739 rows. Alright, so there we go. So we got all of our indices, and this will be something that you will have to do in your project. So, we're going to talk about it in more depth on Wednesday, but your project is still going to be around COVID data, but it's different than last semester. So last semester I had COVID data for cases and deaths and hospitalization, stuff like that. This semester we're going to do it on vaccine data because there's a lot of vaccines coming out now. So we're going to use that for vaccine data, and you're going to have to use this kind of method here, at least for finding indices for each county. So we're doing it for California counties, and basically you're going to have to find every single time, like, Orange County shows up or Los Angeles, something like that. Okay, so there's a question. For a cell array, we would use it when the player showed up on the same number of times. So I don't really understand your question, but basically we have to use a cell array here because these players, they show up a different amount of times. Player number 1 is Mike Trout. He showed up 1023 times. Player number 2, he only showed up 906 times. So they're different lengths there. So because of that, I have to use a cell array. Okay. Alright, so question, do we need to use the double equal sign? Yeah, so, up here we use the equal sign, and it was only one equal sign. So the equal sign in MATLAB is an operator. It's an assignment operator. So basically, like t equals read table, I was assigning the variable t to make this table. And these double equal signs, they're a logical operator, which we'll also go into more depth later on. But this is basically an equality. So it's saying find when this player name is equal to Mike Trout. We're not assigning it to be Mike Trout. We're saying check if this is true. Check if our player name is actually Mike Trout. So yeah, for this you have to use double equal signs. And yeah, I'll be around after class 2. Alright, so everyone good on this part?
Yeah.
Okay. I think I might make another video too, like sometime this week, just because this stuff is, I think it's good to see these exercises, but they kind of take a while to go through. Alright, next thing, last we'll talk about the differences here for the cell arrays. Okay, so now we want to find the percentage, or how often a player hits a ball over 100 miles per hour. Alright, so the first thing we're going to do is basically avoid our hard coding. So let's say for this plot, I want to find when they hit it over 100 miles per hour, and maybe I want to modify my code later on to be how often they hit it over, I don't know, 90 miles per hour. And in that case, I can write my code in such a way that I only have to change this one line of code to get that to show up. It's kind of like what we did last time when we, I forget what it was back then, but oh yeah, it was how many players showed up in our plot. Let's go back to that. So last time we made this plot, or was it up here? Where's our final plot? Here. So last time we changed this to be like top 15 players, and we could just change one line of code. That's all we had to do. And we could have all of our code update to reflect that it was the top 15 players instead of top 25. So we're going to do something similar here, where we define the miles per hour that we want to look at. So the first one we'll do is 100. Okay, so let's make a variable called 100. So I'll say mph equals 100. Alright, and then that shows up in our workspace where mph, that was assigned a value of 100. Alright, now I'm going to create a string array, which basically contains all of the players that we have. And we're doing this to later on, we're going to have these player names as X-tick labels in our plot. And basically I'm doing this so we don't have to actually type out the player names manually ourselves. So I'll say players, basically I just want to access the player name from our table. So I'll do players11 equals t, angels underscore ind. I'll explain this in just a sec. And then comma 6. Oh, here we go. Alright. So, what am I doing here? Let's make this bigger. Okay. Alright, so basically what I have here is players 1, 1. That means I'm making, in this case it's a table because it's accessing our table that we have here called t. So it's making a table where the first value that we have is basically going to be this over here. So we're looking at our table t. Let's open this up. And then we're using array addressing. Remember, we just found all of the indices for when Mike Trout showed up. So that was right here. Angels underscore ind 1, 1. Okay, so we're looking at our table t, and then we're using array addressing, where we're looking at, where we're basically taking this row here, row 301, and then we're going down, so that's 301, 301 right here, and then we're also looking at column 6 in our table T, which you can see up top here, it says column 6. And this is how we're going to get this name, Mike Trout. Let's go over this part one more time too. Okay, so we're going inside of angels underscore ind right here. So that's why we have, let's go back again. Okay, so we're looking at angels underscore ind. This is our cell array here. And I have in curly braces 1, 1. That's our first cell right here. And then right after that, I have in parentheses a 1. And I have to put that because that's array addressing inside of this cell. So that's basically looking at this first index 1. So if I was going to use 2 instead, that would correspond to this index here. So we're kind of doing double array addressing, or array addressing inside of an array. Okay, and then you can see that as a result we get in this table that we just created, Trout, comma Mike. So I want to do this for our other two players as well. So then I'll do, oh yeah, okay, I'm going to make this a column vector basically. So I'm going to add in these new rows. And then I'll do 2, and then I'll do 3. And now if I run this and we look at players, then you see that we have our other two players that are in here as well. Alright, so why am I only looking at one? So I think you mean inside of these parentheses here. I can put any of them. I really just need to find, it could be literally any of these rows in here, because any of these rows stands for a row that this player shows up in our table T. So basically you can just choose any of them. It's arbitrary in that sense. I just want to reference some row where Mike Trout shows up in our table here. So I can change this to 100. And I'll run this, and I'll look at players again, and it's still Mike Trout. Does that make sense? I'll go through it one more time, because I know a lot of this stuff, it's a lot of things going on at once. So, okay, so table T, that's this table here, and we want to basically use array addressing to get an output of Trout, comma Mike. So to do that, we're going to use array addressing for our table using what's highlighted here. So we have angels underscore IND, and inside of our curly brackets, we have 1, 1, which corresponds to this first cell. And then in parentheses here, we're doing array addressing inside of this cell. So in parentheses, when we have a 1, that means that we're looking at this first row in this cell array. And by doing that, we are then accessing essentially row 301 in our table T, which is right here. And then we have comma 6 at the end, which means column 6 in our table T. Okay. I know it's a lot of stuff, so you might need to, watch this video a few times to get it. And definitely go through it yourself. I think that is the best way to learn how to use MATLAB is going through these exercises yourself and I don't know, coming up with different things that you want to plot yourself too. So, you can use this table if you want, or download whatever data you want to download and kind of do an exercise similar to this, and you'll start to really pick up on it. Okay. A lot of talking. Okay, so now we want to find our, we're going to use a logical operator now to find when a player hit a ball over 100 miles per hour. Where did I get this data? I got it from a website called Baseball Savant. You can put in the chat. So yeah, you can use that website if you want baseball data, and you can get so much data on there. It's amazing. Alright, so now we want to find if a player hit a ball over 100 miles per hour. Okay, so we're kind of using two different functions again in one line here, so I'm going to have to break this down as well. Okay, so I'm going to make basically a new array here, which will just give us a scalar. So if I'm looking at Mike Trout, basically I want to get a scalar that says how many times he hit a ball over 100 miles per hour. So was that 300 times in this season? Was it 50, 25? We want to find that out. So I'll type in GE underscore 100. Doesn't matter, but just for greater or equal than 100. That's how I thought of it. And we'll do 1, 1. Okay, I'm going to build this array. So this will just be currently just one value here. And let me first type this out and then I'll break it down. So we have length and then find. Then we have angels 1 1. Yeah, I need to change this to T. I wrote it down differently in my slide here. Let me think about this. So I need T. Oh, I think I skipped. Yeah, I skipped something. Let me open up my script. We could do it this way too, but then it would make this line even longer. So let me open up my script from last time because I think I forgot to include a little section in my code or in my slides. And what did I call it? Oh no, this is what I'm currently in. So here. Yeah, okay. Yeah, I forgot a little section. Alright, sorry about that. So let's make this section here. So I'm going to make basically another cell array, which is now going to contain all of the data for these 3 players. So I'm going to comment all of this out. Pretend that none of this existed yet, okay? Let's get it out of here. Alright, so we have our indices here for each player, and we're going to use those indices now to create a whole new cell array, which is going to contain all of the data for those 3 players from our kind of main table. So I'm going to call the cell array angels. Now I'll do 1, 1. And now we're going to use array addressing for our table. So we have T, angels, IND, 1, 1. Actually, I'll do this. Okay. Alright, so what is this doing? We're creating a new cell array called angels. And in this first cell, we're going to have a table this time that contains all of the rows and all of the columns for our first player, Mike Trout. So we're looking at our table here and we're using array addressing because we know all of the indices when Mike Trout shows up. So we're going to get all of those rows and all of those columns when he shows up. So you can think about it like for these few rows here, we're getting all of those rows and all of these columns. All right, let's run our script now. Oh, okay, here it is. Okay, let's open that up. All right, so this is what we just created. So you see that we have 1023 rows, and that makes sense because we had 1023 indices for Mike Trout, and we have 89 columns because our table had 89 columns. So I can open this up, and this is all of the data that has Mike Trout from our table. All right, and then we want to do this for our other 2 players as well. So I'm just going to change this to a 2. This will be a 3, so this stands for cell 2 and then cell 3. And now let's get the indices for those players as well, or we're going to use those indices. So 2 and 3. Let's run this again. And there we go. So now we also have a table for player 2 and a table for player 3. Okay. Alright, now we're going to find how often they hit a ball over 100 miles per hour. So let's bring this back up. Okay, so we're going to use 2 functions, so I'll explain this after I type it out. I'm sure it's already clear, but you guys can tell that the class is kind of picking up now, right? It's the complexity is increasing just by nature of what we're starting to learn. So, I would say that this part and looping, they're probably going to be the most difficult parts to understand in this class. But if you can kind of break it down and think about things kind of step by step, then you should be good. So you'll want to make sure that you watch this video a few times or go through an exercise like this a few times to really get it. So first thing I'll do is I'll run my code. No, you don't need McDonald's, okay? You can do this. Alright, so if I just run my code and I look at what we just created, we have a number of 58. So this is telling us that our first player, Mike Trout, he hit a ball over greater than or equal to 100 miles per hour 58 times in the season of 2020. Alright, so let's break this code down. To the very top, okay. Yeah, in and out. Alright. Okay, so let's break this code down. So we're looking at, we're using two different functions here, length and find. And we're also using a logical operator. So up here we used a logical operator, which was our equal sign, which is basically inequality. And down here we're using a logical operator of greater than or equal to. So, this part here, that's easy enough to understand. We're saying, is the launch speed greater than or equal to 100 miles per hour? I shouldn't have 100, I should have mph. Okay, we have mph, and that corresponds to this variable which we created, which was assigned to 100. Okay, so what we're doing is we are finding the length, or the amount of times when this part is true. So find angels 1, 1. We're looking at our first players, that's Mike Trout, and we're looking at, I'm trying to think about the best way to break this down because there's a lot of things going on at once here. Let me hide this really quick. Let's go over here. Let's resize it. Okay. So let's do it this way. You should already understand this part. This is basically just to think about, do we have a launch speed that's greater than or equal to mph, that's 100 miles per hour. So we're looking in angels 1, 1, so that's this table here. That's this table in the cell array called angels. So we're in here, and we're looking also at the row called dot launch speed. So let's go over here. Okay, that's row or column 54. So we're looking at this entire column vector. All right, and we're finding when a value in here is greater than or equal to mph. Let's move this up here now. So if I just type in the command window, find angels 1, 1 dot launch speed greater than or equal to mph, you'll see we get all of these values here. So all of these values, they correspond to the row when this was true. So you see that we have 1 that was true. So 111, that's greater than 100. So that's good. That's why we get this output here. And then we have row 2, that's 104. That's also more than 100 miles per hour. Row 14, 102, good. And you see like row 15, that was less than 100 miles per hour. So that doesn't show up in our result here. Okay. Didn't want to do that. Just drag it down. My system is a little weird. Okay. Let me go back here. Layout, default, there we go. Okay, sorry. There we go. Okay, we're back now. Okay, so does everyone get this line of code, or does anyone need me to go over it again? Okay. I'll go over it one more time. Let me change these. Yeah, that's correct. Yep, it's finding the length for how many times Mike Trout hit a ball over 100 miles per hour. So length in this sense, it's the amount of times that he did it. Okay, so we want to break it down again. So basically, what we're doing is we're in our table called Angels, and we're in the first cell array. So that's for Mike Trout. So over here to my workspace, that's what we're currently looking at. Let me make this smaller. I'll make this bigger. Okay. All right, so we're in Angels 1, comma 1. So we're right inside of this table, which is right here. And you can also see it says Angels 1, comma 1 right here. And then we're in the column called dot launch speed. So that's column 54. Right? And then we're looking for when we have a launch speed that's greater than or equal to mph, which is assigned to a value of 100 miles per hour. So let's actually just do Angels 1, comma 1 dot launch speed greater than or equal to mph. If I run this now, we're going to get a result of ones and zeros. So remember that greater than or equal to, that's a logical operation. So that's going to give us a logical result of a 1 or a 0. So a 1 means true and a 0 means false. So if we go up to the very top, you see that our first two rows here are 1s. That's because these first two rows are greater than 100 miles per hour. Okay, so we have that, and we're combining that with two other functions, which are find and length. Okay, so we just ran this line of code here. Let's add on to this now, the find function. So now if I run this, MATLAB is going to return all of the values when it was true that the launch speed was greater than 100 miles per hour. So we should see at the very top 1 and 2, because that's these two rows here. The next one is 14. That's row 14 right here. Right, and then we're adding onto this now another function, which is the length function. And that will calculate the length for what we just saw in our command window. So how many times did Mike Trout hit a ball over 100 miles per hour? And that's 58 times. All right, and then we do the same thing for the other two players here. Yeah. Yeah. You can actually write these on different lines of code too, if that's easier for you to kind of understand that way. But either way, it's a lot easier to understand this stuff if we break it up like that. Yeah. All right. So, yeah, give me a sec. So let's open up what we just created, which is we gotta run our code now. So player 1, Mike Trout, hit a ball over 100 miles per hour 58 times. Player 2, 5 times. Player 3, 28 times. So I guess we're going to stop here for now. I really thought we would finish this one, and even the second one, but nah, it's not the case, which is totally fine. It's a lot of stuff to take in. So semi-log and log, I'll go over that if we have time, but that's not going to be on the quiz, so I'm not going to go over that right now. Let's go over xticks and xtick labels. So that should have been on the homework. So I'll open up the homework. All right. Let's see when we had one. All right. Problem number 6. We have it. All right. Yeah, let's look at problem 6. Let's open up the homework 2. Okay, so homework or problem 6 on the homework, we were making this graph. So we're not going to do all of it right here. Let's just go over the more important parts. You're not going to have a question on two y-axes for the quiz either, so I won't go over that part. But let's go over how we can set up the ticks and the x-tick labels. I'm going to comment that out, and I'm going to turn this graph on, or let's just do figure 1. Okay, so if I run our code right now, and this is what we have. Oh, it's bugging out. Let's do it again. There we go. Okay, legend, you chill out right now. Okay, so here we go. This is what we have. And we want to set up our tick, so we go from 2 pi, that should be negative 2 pi, negative 2 pi to positive 2 pi. And we have 5 ticks that we should have. And here we have 1, 2, 3, 4, 5, 6, 7, 8 ticks. So we have to adjust the amount of x ticks that we have, and then we need to adjust the x tick labels. So starting out with x ticks, we can define this by basically using a row vector or creating a row vector. So I'll type in x ticks, that's our command. And then we want to have our x ticks go from negative 2 pi to positive 2 pi. So let's do negative 2 times pi. That's where we start. We're going to use a step size of pi. And then we want to go to positive 2 pi. So if I run this now, we're still going to have numbers here, but our actual spacing that we have is going to be from negative 2 pi to positive 2 pi. Alright, so that's why you see the numbers change to decimal format too. So now we want to change these x-tick labels to be from negative 2 pi to positive 2 pi. So to do this, we can actually just write it out like you see here. So let's do x-tick labels. And we need to use, we're going to have parentheses, and then inside of our parentheses, we're going to do curly braces and then single quotes, and that makes a character kind of array. But in this case, that's okay. This is going to display fine. So in single quotes, we're going to put all of our x-tick labels. So negative 2, and then we have to do a backslash for pi to get the pi symbol to show up. Oh, we have negative pi. Oh, jeez. Okay, negative pi. Then we have 0. And then we have positive pi. And then we have positive 2 pi. Jeez, come on. There we go. Let's run this now. And there we go. Our x-tick labels are updated as well. Alright. I forget if there was another question that you guys wanted me to go over.
I have a quick question. It's about how you input the equations. I noticed that you put a period after the x sometimes.
I use a period for the tables. Do you mean that?
Like for y2 equals sine x, 3 times x.
Oh, yes, yeah. Yeah, that's for an element-wise operation. So remember when you have to do element by element multiplication or division maybe, and when you have to do matrix multiplication or division. So if you have like two vectors, like, let's see, where do I have it here? Like here, I have sine of 3x and then e to the negative 0.2 times x. This is a vector here, and this is a vector here. I'm multiplying them. So I have to do element-wise multiplication, and that's when we have that period.
Oh, okay, that makes sense. And then I have another quick question. I noticed that you put the money sign sometimes on the legend. I was wondering what's that for? Is it when you're trying to, yeah, I just don't get it.
Yeah, don't worry about the money sign thing. That's for using LaTeX formatting that we talked about a few times, but for your quiz, you don't have to worry about the money sign.
Okay.
Yeah. Okay, AX equals GCA. We're running out of time here, but AX equals GCA. You have to use it sometimes, it depends. So here we did it. This was just for exporting my graphics though, so don't worry about that part. There was one with exponents. Which question was that? The last one, okay. So for this last question, we wanted to have our exponents be times 10 squared, basically. So to do that, we have to access all of the properties for our figure. So to access those properties, we use ax equals GCA, and then we use dot notation to then access basically the y-axis properties, and specifically the exponent properties for that axis. And then we set it equal to 2, because I wanted to have our exponents be times 10 squared. Okay, I'm really running out of time here, so let's open up the quiz right now. You can come over here. Yeah, so I'm gonna open up the quiz and I'm gonna explain quickly some of the instructions. They're on the quiz too, but we'll talk about it. Oh no, it's bugging out again. Okay, I have to unpublish it really quick and I'll publish it again. For some reason, oh no, it's still not working. Okay, it won't let me look at the quiz for some reason. It'll still be published. There we go. Okay, so make sure you read these instructions. You're going to copy and paste your code into this text box at the bottom. You know what, guys? Hold on. Let me change the time. I'm going to add on some time so I could talk about the instructions. Okay. Okay, I'm going to put this to 350 so we can go over it a little bit more. All right.
Was this do 350?
Yeah. Okay, so make sure that you copy and paste your code into the text box. So if I do a preview, so here's the text box down here. So you're going to copy and paste, or you're going to paste in your MATLAB code into this text box. So if you're in MATLAB, just copy it in there and paste it into this text box. And that's all you have to do. And then, press submit. Make sure that you turn it in on time though. That's really important. Next thing, you don't need to worry about writing code for these things down here. So you don't need to worry about the position or the visibility for the graph. You don't need to worry about the line width for the curves. And you don't need to worry about the text size or LaTeX formatting. That's with the dollar signs. And you don't need to worry about exporting the figure. Alright, so that's it. So it should be open now, so you guys can get started on it right now. And good luck. I think I need to change one more thing. Let me stop sharing my screen. So you can get started on the quiz right now. Okay, I just modified the time to be 20 minutes, so it should say that you have about 18 minutes left for the quiz right now. If it doesn't show, just refresh the page and it'll show that. Okay, I'm gonna mute my mic.
Actually, Patrick, it says for me 15 minutes or so.
Yeah. Did you refresh the page?
I did. Hold up. Yeah, it still says 15 minutes.
Okay, you can try exiting the quiz and then go back to it. It should be updated, because that's what I see.
It didn't for me.
It says 13 minutes for me too.
It says 13 minutes.
Same
When
here.
when I refresh it, it just like keeps the time going.
Yeah, you might need to fully exit the quiz and then go back.
Okay, go to EGME. Quizzes. Yeah, it just keeps going from 13 minutes.
Okay, I hate Canvas. Okay, just work on it, and basically I'll give you guys 5 minutes after where you can send it on Discord if you don't have enough time.
Write code for the following. Write code for the following.